Okay, now that we have gone through a great deal of RGB or colored images having 3 channels and grayscale images that has just 1 channel, that is a grayscale channel. There are so many images that has more than 3 channels, and sometimes these images are known as hyperspectral images. So what happens basically is the light that is coming to the camera, it has different wavelengths. So R is a particular range. Red channel belongs to a particular range of the wavelength. Similarly, green belongs to a particular range of the wavelength, and blue also corresponds to a particular range of that wavelength. So blue. What happens is the camera has red, green, and blue sensors in it, and the red sensor only captures the red wavelength and records the red wavelength, and the green actually captures the green wavelength and records it, and blue captures the blue wavelength portion and records it, and the rest of the information or the wavelength in the light is just thrown away or discarded. And these RGB channels are basically recorded in the camera. There are sensors that actually are capable of recording the other ranges of wavelengths as well. And if the wavelength is divided into multiple such ranges, for example, other than RGB, we have near infrared and ultraviolet and a lot of other ranges. And there are sensors that can record these. Then rather than having 3 channels, the image can have multiple channels. So one pixel will be having a red value, for example, a green value, a blue value, a near infrared value, a ultraviolet value, and maybe several other values depending upon how many bins of wavelengths are designed and how many sensors were there to capture each bin individually. And you might be wondering why these hyperspectral images are important. It turns out that different kind of wavelengths, for example, let me show you one example. It turns out, for example, when the light appears on an object, and it get reflected, and the camera actually, that camera actually captures the reflectance of that light, then what happens is different kind of materials, different kind of objects, they have different kind of reflectance properties in different ranges of the wavelength. For example, in crop yield estimation, or finding out a particular type of a rock, maybe the red, green, and blue ranges of the wavelengths of the light are not that helpful as compared to the near infrared or ultraviolet lights. Or maybe there are NVDI indices and DVI index or NVDI index. I just don't remember. NDVI index or NVDI index. I guess it's NDVI index. That is basically ratio of 2 different wavelengths that actually tells the crop yield, or it can tell the content of water in a leaf in a crop, or it may classify the type of the rock upon which the light hits and then get reflected. So different kind of wavelengths and different capturing a lot of information that is there in light can sometimes helpful, and it can give you information that just red, green, and blue channels they cannot give. So you have rich information if you really want to. For example, the satellite imagery actually records hyperspectral images because it has to do a great deal with the underlying material on Earth for which the imagery is performed, rather than just doing the RGB aesthetics. It has to do a lot with material types, the content of the water in the leaf, in leaves in crops, and a lot of other stuff. Maybe you, for example, through satellite imagery, you can find out that the build-up area is residential or non-residential. Are these mud houses or or very concrete kind of rock houses and stuff like so. And based on that, different decisions can be made. So, the final remarks for this module is the images can have more than 3 channels. They are recorded with special kind of imaging setup, and they can be processed using Python and MATLAB and other kind of, there are special packages for these. But normally in computer vision, in most of the cases, people deal with RGB images, but the same kind of skill set can be extended to hyperspectral imagery as well. So with that, I guess you have a very good understanding of what images are, how they are saved in images, how they are saved in computer as data structure, and how can we play with the images using Python, in particular using Matplotlib and OpenCV. Hope to see you next time.